So today we're looking at Glencoe Course 2 Math, and we are looking at Lesson 3.3 on subtracting integers. In Lesson 3.1, we looked at what an integer was, which tells us that an integer is a non-decimal positive or negative number. We have to know what that is. We have to know what an integer is for this lesson. Okay, so it's a positive or negative number that does not have a decimal or a fraction with it. We're not looking at percentages. And the number 0, because 0 is neither positive nor negative. Okay? Absolute value was also in that lesson, and that tells us how far away from 0 a number is on a number line. We had to know what that is. Okay? Yesterday, and in Lesson 3.2, we looked at how to add integers. We're going to be using those rules from adding integers when we subtract today. So can somebody tell me, what do we do if we have two positive numbers that we're adding together? What do we do if we have two positive integers that are being added together? You want to guess? If I have a positive plus a positive, what am I going to do? Yes, sir. I'm going to move on a number line to the right in the more positive direction. So what is my answer going to be, positive or negative? Positive. And I just add the two numbers together? Okay, cool. What if I had a negative plus a negative? Yes. I'm going to move to the left on a number line, which means that my answer will be what? Negative. And what do I do with the two numbers? Do I add them or subtract them? Add. Right, I'm still going to add them. Okay? What if my signs are different? What did our rules tell us to do then? If we have a positive plus a negative or negative plus a positive, what did our rules tell us to do in that situation? You want to go back and look? I believe you wrote the rule down on page 207. Shh. Was it 207?
205.
Oh, you turned into a 7. Okay, sorry, on page 204, 205, you told me what to do. I'm sorry. Page 204, 205, you wrote down the rule if the signs are different. What are we going to do if the signs are different? Yes, ma'am.
You subtract and keep the sign of the greater absolute value.
Okay, so we're going to subtract the two numbers and keep the sign of the greater absolute value. All right. Today, we are going to subtract integers. The way that we're going to do this, I'm going to show you a model of a subtraction problem. Then I'm going to give you the rules for subtracting. Okay? Everybody got it? Okay. I need let's do this. At the top of page 216, it gives the problem 6 minus 7. So let's do that. 6 minus 7. First of all, when you look at that, can we take 6 minus 7? Can we do that? No. All right, so you guys are telling me that based on our current subtraction rules, we cannot do that. Yes, sir. You think we can? As it's written? Not, okay, so you're saying we're going to have to rewrite it in some way. All right. Let me show you how we model this and how what we're going to do is the same. All right? So let's say that I had 6 cubes. I'm going to draw them as dots. 2, 3, 4, 5, 6. I have 6. Now, I'm supposed to take away 7. So I'm going to take away 1, 2, 3, 4, 5, 6. I have to take away another. But I can't take it away like that, can I? There's nothing to take away. So what I have to do, I have to add in a 0 pair. Somebody tell me, what was a 0 pair? What was a 0?
Positive and negative.
Right. It's one positive and one negative, and they cancel each other out, correct?
Uh-huh.
Because when added together, they equal 0? Good. So I'm going to add a positive and a negative. Then can I take away my 7th? Yeah, then I can take away another positive. What am I left with?
1.
Now I'm left with -1. So 6 minus 7 equals -1. Okay? Now, that kind of makes sense. But, what if we had -6 minus 7?
Oh.
What if we had -6 minus 7? Is it going to work like that? I could draw it and show it for you, but it's not going to work real well. So let me tell you what we're going to do instead. The rules for subtraction. We're going to KCA the problem. K stands for keep the first term. We're going to change to addition. And I just realized I started vertical and went horizontal. And we're going to take the additive inverse of the second term. So now do we have to know what additive inverse means?
Yes.
Yes, we do.
Yeah.
The additive inverse, in technical terms, is a values. Additive inverses are two values that when added together have a sum of 0. That means that if we take two numbers, we add them together, we get 0. Does that make any sense to you? Not really. Okay. Do math definitions usually make sense when we start looking at them just like that?
No.
No.
Not at all.
Not at all. All right. So let me tell you what this looks like. The additive inverse is a number's opposite. So if I was looking at the opposite of 7, what's the opposite of 7?
Not make -7.
-7. What's the opposite? We had 7 here too. What's the additive inverse or the opposite of -2?
2.
2. What is the additive inverse of -6,000? 6,000. What's the additive inverse of 1,324,000? Negative whatever number I said, right?
Yeah.
Okay, so the additive inverse means that we take the opposite of that number. Because any number plus its opposite is going to equal 0. Did we find that yesterday on some of our problems? Where we had like a -6 plus a +6?
No. No.
Are you saying yep or nope?
Yeah.
Okay, I'm glad that we're saying yep. Alright? So, any number plus its opposite is going to equal 0. Those are additive inverses. Okay? So, we did this problem using a model. Let's try it using our rules to see if we get the same thing. Sound fair? Yes. Okay. Because we're doing the same problem, I'm going to use the same color. We start out with 6 minus 7. I'm going to KCA it. That means that I'm going to keep the 6. I change the subtraction to what?
Addition.
And I take the additive inverse of +7, which is?
Negative.
Okay. Now, my rules of it, now I have an addition problem, don't I?
Yes, ma'am.
Yeah. What is 6 plus -7?
1.
So,
Isn't it?
what do I need to do if my signs are different?
Put a slash.
Okay, so I need,
-1.
hold on. So I need to find which has the highest absolute value. Which has the higher absolute value, 6 or -7?
-7. -7.
Which one? We seem to have some confusion. Hold on. I don't want to know which number is bigger. I want to know which has a higher absolute value. Which one is further away from 0 on that number line?
6.
7. 6.
The -7. The -7 is going to be further away from 0 on the number line. Because if my 0 is in the middle, we have -1, -1, 2, -2, 3, -3, 4, -4, 5, -5, 6, -6. Then we have 7, -7. So the -7 is going to be further away from 0. That has a higher absolute value. So that means that my answer will be what? Negative. Okay? If that -7 has a higher absolute value, my answer will be negative. Then, I need to subtract the two numbers. What is 7 minus 6? 1. So using my rules of addition, after I KCA'd my problem, did I get the same value that I did when I modeled it?
Yes, ma'am.
Yeah. Okay, let's try another one because we're not real sure yet. Okay? Let's look at example 2. It says -10 minus 7. -10 minus 7. If I have -10 minus 7, do I know how to solve that?
Yeah.
Okay, what am I going to do? Somebody raise a hand and tell me, what am I going to do to solve -10 minus a positive 7? Yes, ma'am.
You're going to KCA.
I'm going to KCA it. And when I KCA it, what does the K tell me to do?
Keep.
I'm going to keep the -10 just the way it is. What does the C tell me to do?
Change to addition.
Change to addition. What does the A tell me to do?
Add.
Additive inverse?
Yeah.
Okay, what is the additive inverse of a positive 7?
-7.
-7. Now I have a negative plus a negative. That's easy peasy. A negative plus a negative will give me what kind of answer?
Negative.
Negative. 10 plus 7 is?
17.
So now I have -17. So we kind of got it here when we modeled. But we don't want to have to model everything. That takes too long. That's very elementary. We want to be like middle schoolers. So we're going to KCA it. Here we had a little bit of trouble. Do we feel better here?
C.
Yes? Do we need one more problem to make sure?
No.
Yes.
Let's do one more just
Yes.
to make sure. Let's do one more just to make sure. Let's do example 4. Example 4. Example 4 tells us that we have 10 minus a -7. Wait. -10 minus a -7. First of all, these look similar, don't they? They do. But our answers are going to be very different. Our answers are going to be very different. Okay? So, what am I going to do with -10 minus a -7? I'm going to KCA it, absolutely. What does the K tell me to do? Keep. The K is the easy part. What does the C tell me to do? Change to addition. What is the additive inverse of -7? Because that's what the A tells me to do. That makes it a positive 7. Okay? Now I have -10 plus a positive 7. If I'm adding and my signs are different, what do I need to do?
Make
Subtract and keep what?
the negative.
Keep the sign of the greater absolute value. Okay? So, what is 10 minus 7? What is 10 minus 7? 3. Which has a higher absolute value? Negative 10 or positive 7?
Negative 10.
So my answer will be?
Negative.
See, I said that.
Great. But you answered it before we were ready. Ladies and gentlemen, starting out with negative 10 minus a positive 7 and negative 10 minus negative 7, we went from an answer of negative 17 to an answer of negative 3. And the only difference there was one more negative sign. One negative sign meant that our value changed 17, not 17, our total answer changed 14 units by one little negative sign. So what this tells us is that we're going to have to pay attention to details, like negative signs, okay? All right. This lesson asks us to do one more thing. And in that, one more thing, look at example 5 and 6. In example 5 and 6, it tells us that we might be asked to substitute for a variable and then subtract. So I'm going to let you choose. Would you like to do example 5 or example 6? Give me an open hand if you want to do example 5. Give me a closed hand if you want to do example 6. Thumbs down doesn't do anything, honey. We're either doing 5 or we're doing 6. Okay, the 5s have it. Example 5, and we are on page 217. What color haven't I used yet today? We'll use red. Okay. We'll do example 5 over here. Example 5 asks us to evaluate x minus y, but it tells us that x is equal to negative 6, and we're going to subtract from negative 6 y, which is negative 5. Negative 6 minus a negative 5. Negative 6 minus a negative 5. So, what am I going to do to solve this problem? I have a subtraction problem. What do I need to do? Yes, sir. I need a KCA. What does the K tell me to do? Keep. All right. What does the C tell me to do?
Change.
Change to what? Addition. Thank you. It's not telling me to change its color. It's not telling me to change to division. It's not telling me to change and let you use a calculator. It is telling me to change it to addition. What does the A stand for? The opposite, which is what math word?
Advertisement.
Inverse.
The additive inverse. Okay? Ladies and gentlemen, you will have questions. You will be asked to tell me what the additive inverse of a number is. So if we don't use that word additive inverse, are we going to know what that means?
No.
Nope, which means we get that problem wrong. Do we want to get a problem wrong because we don't know vocabulary? No, I don't want you to do that. You don't want to do that. So that's why we don't call it the KCO words, keep, change, opposite. We KCA it. And the A stands for what? Additive inverse. Say that one more time for me.
Additive inverse.
Thank you. And what is the additive inverse of negative 5? 5 or positive 5. Okay? Now I have negative 6 plus a positive 5. If my signs are different when I add. What do I do?
Subtract.
I subtract. What is 6 minus 5? 1. Which has a higher absolute value? Negative 6. The negative 6 has a higher absolute value, which means that our answer will be negative, giving us -1 as our final answer. Okay? Ladies and gentlemen, I'm not going to tell you to go home and memorize anything. Okay? Because in my experience, when I tell you to go home and memorize something, you know it the next day and not a week from now. What I am going to tell you, can we just kind of forget about those rules of adding? Nope. Do you think we're going to use these like all year long? Yeah. Yep. So, we're going to keep practicing, and we need to get better and better and better at knowing what to do without needing to look back. At some point, when you look back, you're going to get tired of looking back, aren't you? Okay? If you need to dog ear or turn down the page where you put your integer rules for addition, do it. Because we are using those same rules when we subtract, aren't we? We use the same rules to add that we do when we subtract. All right.